Alright, I think we are at this stage where we should talk about a very common word that you might have heard from your colleagues or maybe from your friends, or maybe you might have discovered it while browsing through web, and it's called oops. And now I'm not talking about the English word that you say when you do some mistake. I'm talking about a programming methodology in computer programming world. The full form of OOPS is Object Oriented Programming System, and it's a methodology to tell you how you should write your code with better efficiency and readability. A lot of programming languages out there uses OOPS in one way or another, starting from C++, Java, C#, .NET, and our very own Salesforce Apex language too. And in this video, we'll be talking about exactly this, OOPS in Apex. So let's try to break it down one by one. We say OOPS is Object-Oriented Programming System. So what is this object? So to understand it, we can say an object is a real-world entity. And we have already seen some examples in this course that gives you some hint about an object. We had few examples about storing student information, right? We had stored student roll number, sometimes we had stored student name, and so on. And a student is a real world entity. So we can say a student is an object. A dog is also an object, a car is also an object, and similarly a mobile, a laptop, a person, a house, a country, all of these things are objects. Anything that you see in real world are objects. Even a website is an object. So not that hard to understand, right? So all of these objects has some properties. And let's take our student object as an example. A student has a name and age. They should also have a roll number assigned to themselves and a class name as well. So all of these different attributes about a student are called properties. Along with these properties, an object also have behaviors like a student has to mark his attendance or pay his fees or get his dues or maybe write an exam. So all of these are behaviors of a student. So these properties and these behaviors defines an object, or you can also say they gives an object a definition. Without these properties or behaviors, a object is nothing, it's null. Now let's come to the second question. How do you represent an object in a programming language? So most of the programming languages, they use a class to represent an object or to give an object a definition. A class is used to store the properties and behaviors of an object, where the properties are called variables and behaviors are called methods or functions. So in plain English, to define a real-world entity in a computer program, you use classes. Or you can also say a class is a bundle of an object's properties and behaviors. And generally you name your class after the object it is defining. But it's totally up to you how you want to name your classes. Now let's take a look how a class could look like for a student object. First you write the special keyword called class to tell your Apex compiler that you are about to create a class, and then you write the class name. So here we have given the class name as a student. Then you declare all the properties of that object as variables, and we have already seen variables in previous videos of this course. And in the end you write functions or methods to define your object's behavior, like marking an attendance or getting the dues or paying the fee or maybe writing an exam and so on. Okay, so far so good. And now let's move on to discuss the pillars of OOPS. OOPS has many concepts, but it has four main pillars. The first one is encapsulation, which is about bundling your code. The second is abstraction, which is about hiding your code. The third one is inheritance, and this one is about designing your code layout. And the last one is polymorphism, which is about giving multiple definitions. These pillars are the core concepts of OOPS, and now let's talk about each pillar in detail. So first let's talk about encapsulation. I picked an example from our list video, and this is how we used to store the student roll numbers. We did not have any mechanism to store all the properties of a student, right? We could not store the roll numbers, name, the age and class name together anywhere because we did not have any mechanism to store all these properties of students. But now let's take a look at this student class, and we can clearly see how well it defines a student. It contains all the properties of a student, and you can add more properties as well. It also defines the student behaviors like marking the attendance and paying the fee. And this bundling of variables and methods is called encapsulation. And in OOPS, we do it with the help of classes. Now let's talk about the second pillar, which is abstraction. It is possible that some of your properties of a student should remain secret, and no other piece of code or class should be able to see these properties directly. Let's try to understand it with a real world example. So let's say you have a gaming controller which has few buttons to play your games. But you should not be worried about how these buttons give commands to your game, or how the internal structure of your gaming controller looks like, or how different wires are joined together in your gaming controller's socket. These all things are hidden from us, and this is called abstraction. And OOPS also provides us this abstraction feature where you can hide some complex piece of code or some sensitive piece of code or properties from all the other classes or objects. Let's take a look at this student class again. And for now, we are not using abstraction here. Although the abstraction comes by default with each and every variable, method or class that you declare, which is like the default scope of the class and the variables. But you could rewrite your class like this. You can make your properties private, so no other class can see these properties. However, you can make some of your methods public so that the other classes can interact with this class with the help of these public methods. These keywords like private or public are called access modifiers, which control the level of abstraction for a method or for a class or for a variable. Apex has three access modifiers: private, public, and global. And we will be learning about all these access modifiers in detail in further videos of this course. Now let's talk about the next pillar, which is inheritance. We all know the meaning of inheritance. As being a human, we inherit some of our qualities or habits from our father along with our DNA, and we also inherit some of our qualities from our mother as well. And on top of that, we have our own unique qualities and habits. The same thing is possible with OOPS as well. Let's understand this with the help of this example. You have three shapes. The first one is a rectangle, the second is a triangle, and the third one is a circle. And all these different shapes have few things in common. They all have a surface area and a perimeter. Although the logic of area calculation and perimeter calculation cannot be same for all these different shapes, but each shape can define their own formula for area calculation and the perimeter calculation. So we all agree that a rectangle or a triangle or a circle is nothing but a shape, and they all inherit some of the shape properties like calculating the area or calculating the perimeter. Now let's take a look at how you implement inheritance in Apex. So first you define an interface with the help of a keyword called interface, and then you give it a name. So here we are naming our interface as shape. This interface should have base layout for a shape like its behaviors. And whenever this shape is being implemented or inherited somewhere, then these common behaviors needs to be defined. So our common behaviors across all shapes are, they all must have a method to calculate the area and another method to calculate the perimeter. The interface cannot give definition to these two functions or methods because each shape that will inherit this interface will define their own formula to calculate the area and perimeter. So here you can only declare your methods but cannot give them definition. Now we have a class called rectangle, and this class inherits our shape interface with a special keyword called implements. Any class can inherit multiple interfaces. So let's say along with the shape, if you want to inherit another interface as well, then you can give the name of that interface here after a comma. Now as soon as a class inherits an interface, it must give the definition to all the methods in that interface. And in our interface we have two methods. First is get area and the second is get perimeter. So our Apex class rectangle must give the definition to both of these functions. And since our rectangle has its own formula to calculate the area and perimeter, we are going to write our logic in these two methods. Very similar to this, you can have other classes like triangle and circle as well, which have their own logic to calculate the area and the perimeter. So remember, if a class inherits an interface, you must give the definition to all the methods which are declared in an interface. If you do not give the definition to these methods, you will not be able to save your code and you will get a compile time error. So interface is a nice way to create a layout for common functions that all the classes that are inheriting that interface must define. So you are kind of forcing some piece of code on the developers who are inheriting your interface. And we will be using few interfaces in this course that are available in Apex, and we'll also create our own interface as well. Now let's talk about the last pillar, which is polymorphism. In plain English, the polymorphism means one with many forms. And a good example to understand the polymorphism is the power button on your mobile or on your laptops, which does multiple functions like switch on your device, switching off your device, switch on the display or switching off the display. So one button does many things. Another example could be the send button in a chat application where you get different options to send different things. So like with one send button, you can also send the text. You can also send your audio, video and images as well. And now let's see how polymorphism looks in Apex. So it's all about giving multiple definition to a method with same name. So here we have three different methods and all of them are named as send. So the function name is same, but the parameters are different. The first one accepts a string parameter and it is about sending a text message. The second one accepts a blob object or a binary object, which could be an image or video binary, and this one is about sending a single video or a message. The third one accepts a list of blob objects or binary objects to send multiple videos or images. So although the name of the function is same, but we are giving three different definitions to the same function. The thing is, we are using different parameters here. You cannot create a function with same name and same parameter again. So the function signature must be different. You can have the same name, but at least the parameters should be different, else again you will get a compile time exception or error. So I hope I gave you good idea about the OOPS and its pillars, but if you still find it challenging to understand the OOPS concepts, then I highly recommend this answer on Quora. So give it a read to solidify your understanding. So this is all in this video. In the next video, we'll be talking about a Apex class.